Okay, now let's look at the results of the bank teller example with two tellers at the teller window. So now we have total exits is 59.74 and currently there is 2.8 customers, uh, average of the 50 replications, average time in the system, and average time blocked is 0.59 minutes. That is for the customers who have exited the system. Okay. And you can see the entity states 87.5% in operation, 12.5% blocked. So blocked meaning spending time in the waiting line location, and it has dropped quite significantly. Now let's look at the number of customers served is 59.74, so that's from there. And the number of customers entering the entrance. Now this time we don't have to look at the waiting line because all the customers arrive at the entrance. So here are the number of customers who were able to get into the entrance location, which is 60.36. Okay, and then the failed arrivals is 0.48 who couldn't make it to the entrance because everything is blocked up now. But remember, the system that we have modeled the system in such a way that there is a block of 13 customers, and no more than 13 customers can be in the system. That's why we put the capacity in such a way that when everything is filled up, the customer failed to enter uh, the location. So that's that. So we can, between these two, you get the total number of arrivals, 60.36 plus 0.48, and then you divide people who actually made it into the bank by the total number, and you get the service level, which is 99.21%, compared to 85% in the first example. Then we can look at the average wait times. So here we have, if you look at the waiting line statistic, so here it is. Okay, average time per entry, average content. So this is the average number of customers waiting. This is the average time they spent. So wait time for exited customers will come from the entity activity. So that's 0.59. Okay, but here average length of waiting time, which you should include the time spent at entrance as well, because entrance serves as a kind of an extension to the waiting line and to the desk. So if you look at entrance, okay, so average time, okay, average content, okay, waiting line, average time and average content. So you add those two, so you get the number of customers waiting still at entrance, and this is the average wait time customers who are still served customers plus the customers who are still in the system. Now waiting line, so here the utilization, okay, percentage empty, percentage full, okay, so that's 0%. Okay, it is never fully occupied. Okay. So number of time desks are percentage of time. Sorry, desks are empty. Okay, so here we have desk. So percentage of time empty and percentage of time full. Okay, so this is an extension to our bank problem. We've added a couple of new layers. We increased the number of tellers, and then we increased a station, a location called desk. Okay. Now let's look at scenario manager. Okay, where we want to run tellers with capacity equal to 1, 2, and 3. So you can do it with units, right? If you want individual statistics for individual units in the teller, then you can say, okay, we can run the simulation units equal to 1, units equal to 2, units equal to 3. But if you want to automate this process and then run those three scenarios, 1, 2, and 3, in one go and collect statistics for all those three different scenarios, it can be done by altering the units also, and for that you need a little bit, you need to set up a macro. So setting up a macro is easy part, but then to make use of that as a unit, number of units, then it requires a little more um, hacking, and so let's not do that. Let's just use capacities here. So we will have the same model, but we will get statistics only as one single location with multiple capacity. We won't get individual statistics for individual tellers. But that it makes it a little bit easier for us to run the different scenarios. So that's what we will do next.